All right. Hi, everyone. My name is Saba Khalid, and I am one of your presenters for today. And I will be sharing my screen shortly. And Nazmul Ahmed, or Naz, will be your other, I guess, my co-host. Let me
I'll
know
be a
when you
host
guys,
for everyone.
and I'll share my screen. So let me know when you can see it. And everybody can see my screen, I'm assuming. Perfect. So just a quick introduction about me. So my name is Saba Khalid. I'm currently a senior consultant at West Monroe Partners. West Monroe is a consulting firm that's headquartered in Chicago, but it's national. So they have I think 6 cities that we're based out of. I'm based out of New York City. I'm currently living in Queens, New York. I grew up here, and I also went to undergrad locally at Stony Brook. So on the right of my screen, you will see that that is actually me on the corner, and that's post Hurricane Sandy. So Stony Brook's campus was, like most of Long Island, pretty much covered with trees, branches, frankly destroyed. But we had some cool kind of shots being taken because these trees were almost like 60, 70 feet long. So one of the, I guess, aspects of being on campus while Hurricane Sandy was there. There's more fun stories for that if you have time for later, but more about living with 6 to 8 people inside with no food for 3 days, but using like ramen for sustenance. But that's a fun aspect that we can talk about later. So I did my undergrad in electrical engineering, and then I graduated in 2015 and started working for GE, primarily in the energy industry. GE is known to have many branches, so I like to say I was in the overall gambit of the energy portion of GE's businesses. So worked with wind turbines, worked at substations, which is what you're seeing here. One fun thing that I got to do was in my first role at GE, I got to work for NASA, primarily upgrading their systems. But it was a cool introduction, and I thought it was the best job I could ever have. And the NASA folks appreciated it, but they just needed to get their stuff upgraded in time. So but other fun fact about that is that Orion was being tested. They were doing splash testing in Langley, which is located in Norfolk, Virginia. Um, One other aspect about me getting into design thinking, and we can talk more about this later, was actually in undergrad. I participated in something called the University Innovation Fellowship, and that's run by Stanford D School, which is the design school where design thinking kind of really got into fruition, and expanded to more accessible level for everyone, designers, artists, engineers. So I got my training done there in design thinking. It was a 6-week virtual training, so very much Zoom friendly. And then we had a culmination, like almost like 3 or 4 days, where we got to talk with the professors, got to talk with some of the researchers there, and understanding what does it take to bring design thinking to our undergraduate campus. And one other aspect that I just included because I thought it was really cool, this was actually in the High Line in Atlanta, Georgia. And what they did is that there used to be an old Sears factory, where I think it's Ponds Market is now. So they reconverted that into a food hall, but they also took any of the machines that were around there and put art along the High Line. So really cool branch of like engineering, art, and reformation that I thought would be relevant for this conversation. And I will be moving on to Naz, who will be talking about himself. So we will be taking questions at the end, stories and stuff at the end of our introduction. So keep that in mind. I'm not done yet.
Yeah. Remember fun questions for us? Okay. So thanks, Saba, for giving us a quick intro on your background. So starting with mine, Saba and we actually went to the same college, Stony Brook University, and that's where we met. I majored in chemical engineering, so another engineering major. What the way we met was actually through a awesome college program called Engineers Without Borders, which Saba incidentally was the president for 3 to 4 years. I'm not sure how how she forgot about that one, but that was a big part of my college experience. Before college, I essentially just wanted to major where I can get a good job, but coming into myself, working with Engineers Without Borders, I got to work with community development. I actually got to go over to Nicaragua for a bit. That experience really changed what I wanted to do once I got out of college. A big part of that was, we got to use engineering in a way to really scale up how much work any one person can do, how much impact they can have at a community. So keeping that in mind, you can see some of my pictures from Nicaragua. The picture where I'm wearing a great college shirt, that was my dorm room, but dorm building. But we were there helping, I believe we were building a brick building using a design work from the community there so that it would be insulated and fairly cheap to build. So that was really interesting. After graduating college, I essentially worked in the medical device industry for almost 5 years. That was a great experience for me. I got to work on products where I got to keep with my principal. I essentially made parts that I knew were helping out people and communities in need. If you look to the bottom left, you have a typical product we used to make. It's called a DBP Zika. Essentially, you would put in like a sample of your blood or saliva, and it could tell you if you had Zika or not. If you guys remember, we had almost a Zika pandemic a couple of years ago, but thankfully we were able to avoid that. Right now, that same companies are making same product for COVID as well. So it was really delightful to work in the medical device industry. But now currently I'm working on a aerospace defense company making sealing systems as a quality engineer. So that was a brief rundown. And it doesn't seem to relate it to climate change or designing, but that's what the questions are for, I suppose.
Yeah, if there's any specific stories or experiences that you want to ask us about, please feel free to do so because we want to make sure we're addressing any of your, interests and questions. Just to give you some additional background, I did also intern at a utility. So after Hurricane Sandy, I was at National Grid for a summer, just kind of responding to how can we prepare better for, these severe storms that are coming through New York. So I have a pretty strong utility background too. That helps.
So I forgot to introduce what the goals of the series are, which is probably pretty important. Although I think a lot of you participated in the first one. So we're interested in activating a space for collaboration and experimentation around climate change and resiliency, especially relating to water. We want to create a space to explore climate change and the influence of water in our own personal practices and in collaboration with art, science, teaching, etc., whatever we do. We hope that this event will help you find more of a creative way to approach ideas that you may have, and we hope that you meet people that you can then collaborate with in the future, and possibly you'll be collaborating with us, and possibly we'll all be collaborating together. We'll see how it goes. And then, but first, so, we've had our two presentations. We're now going to take some questions. And then after the questions, we're going to go into some small breakout groups. I'm not sure how many groups, but someone else will be doing that. So, and I'll be with one of the groups as well. So, so now we can just open it up to questions.
I think Simona, right off the bat, asked a great question that I think might be worthwhile to speak to it. I'm not really great at typing off the cuff. But so Simone's question was, what is engineering? And for me personally, that's so there's a lot of dictionary terms for engineering. Essentially, it has a base component of, being creative, making designs, creating something that wasn't there before. for me personally, my engineering career, what people come to me is that they expect me to have um, some level of subject matter experience or knowledge about wherever I'm working. So currently I'm working at a machining company. So they expect me to have that knowledge, but then I have to be able to use that knowledge to come up with novel solutions for, problems that no one would know about beforehand. And this can range from a lot of customers using our products and then they get an edge case defect that no one's ever seen. And I have to be the one that can investigate it and answer any questions they have. I'm sure it's different for Saba. So that was my take on it.
Yeah, no, I think it's a good point. I think for me, when I first started, I had an idea what an engineer would be. I was told, if everybody remembers MacGyver, because I know that's not a recent show, but it's been getting reboots. But the idea was like, you are faced with a challenge and you're trying to solve a problem in a short amount of time, and that's most like work. You're given like an hour's notice. Oh yeah, like we're running into these issues. Can you go solve this for us? And here are your constraints. And we're like, oh good, like you can give me like no budget for this. So I think that's a fun way of putting it, but I think it's not engineering broadly. I wouldn't like Naz said, you have a subject matter expertise, which is why you get like electrical or chemical or even biomedical. But I think what kind of ties it all together is this idea of like you have a problem that you're trying to solve with the resources that you have, and those are your constraints. And you have to present a solution that works, right? It might be temporary, it might be long term, but I think at the very root, you are like a problem solver, and you analyze. You're supposed to take all this information you're getting, analyze it, and kind of get to the root of the problem. And that could be coming from customers' complaints too, right? So if customers are like, I'm running into this issue, can you please resolve this for me? So, and then it's our job to be like, okay, like what is really truly the issue? What are we really trying to make easier for the customer, for for the community, for the world? So I would look at it that way. That helps.
So do you feel like, okay, you're an engineer, you went to school for engineering, and I'm speaking to both of you. You didn't necessarily go to school for design, though I know there are certain driven design courses. But do you feel like most engineers are also designers, ones that are working in the field, no matter what their field is, that there is always a design aspect to different engineering work?
Yeah, I think it's interesting because it comes kind of into our presentation of what is design, right? What are you guys viewing it as? I like to think that you have to be creative, mainly not because of like creative. Like normally when I had heard about creativity, it was like always in this artsy sense, right? Creativity is also like you're given like 3 items to fix the problem with. So how do I creatively utilize this and, make sure that whatever I'm doing is going to be transferable or able to be resolved. This is like what I'm trying to get to that problem. So I think in terms of just creativity, I think that has to exist. And curiosity is the biggest one. I feel like engineers are one of the most curious people I've ever met, and they always have questions. And I think that's what makes it pretty good because you kind of also start relearning stuff at that moment. So even though we're all trained, let's say with the same like curriculum that, you mentioned, like there's a design driven class, I think we're really mostly taught how we approach that problem, and then how you resolve it is your creativity. If you're thinking about it, and Naz, you might step in here because I think we felt the same way when you're working on like projects for Industries Without Borders. There's no like guideline to building projects in the developing world. Really, you're kind of using your own like resources and understanding and getting advice from places that you don't really know about. That's how I feel. So
I think, yeah, let me just continue Saba's thought on how creativity affects my job. I think Caroline brought up a great question. How does what kind of freedom of creativity do you have in, my field, medical devices, or Saba's field, engineering? And I think the best way where our creativity shines and the best way why it's required is because, you know, these fields we work in, there are a lot of hard and fast constraints you have to work around that are sometimes universal, like you have time, money, but you also have like field specific regulations. Like I was saying for the medical device, there's a lot of FDA regulations. Where creativity comes into play is that when you're working around these constraints, you are essentially you're setting like a field or a play field where as the engineer, we have to figure out, you know, what shapes of building blocks fit in that field you have set up for yourself. So for me, I see myself as a creative person working in a very regulated field, which in turn actually makes it easier for me to be creative, because if you just give me a blank page and ask me to make something, I'll stare at that page for hours. But you know, working in a regulated environment, it's a lot easier for me.
Let's see.
Yeah, there was a question and
Yeah.
about Anthropocene. I need a definition for that.
It's the human era.
It's
Yeah.
basically humans taking over the living environment.
Yeah,
Um,
yeah, yeah. So I'll repeat the question I read it. Do you both find that within your design or engineering work, we're continuing to design for the Anthropocene era rather than designing ourselves out of the state? I think it's a really good question, especially as we approach climate change. I think right now it has been the way, I'll just say the industry that have been like participating in has always been there to benefit humans, like foremost. There have been regulations in the energy industry, for example, that we're not allowed to you know, build sites in certain areas. We need permitting, but that's mostly come out of government, you know, coming in and providing those policies and guidance. And to be fair, we should have more, you know, more policies and government regulations, because at the end of the day, it's more about I am not an expert on, and in let's say, you know, how maybe biodiversity will get affected in a certain area if I'm building it. But I would want to have, you know, an environmental scientist come in and tell us, hey, Saba, like maybe not like build your wind turbines here because it's going to change up the industry or change up the environment, sorry, in terms of the animals are we going to get affected a certain way, or the, you know, flora or fauna are going to start changing. So I think there is an emphasis on, you know, primary being humans, but I think big one that climate change is kind of bringing to fruition is that climate change is affecting our habitats, which is like putting a nice frame to, oh crap, we should probably care about the other, you know, flora and fauna that exist. And let me know if I'm not answering your question, but I think that's a nice way of thinking, okay, how can we design for the environment we're living in? Because we are also, you know, we're codependent. As much as humans like to say that, you know, we can have lab grown meats, and I think at the end of the day, we still need our own environments to be successful and exist. So I think, is Megan, is that a hand or? Okay.
yeah, also, did Saba and Naz, did you have one more slide you wanted to show before we take any more questions?
No, just our intro slides, questions, and then we would go into the
The
presentation.
activity.
Yep.
Okay, all right, great. So
Yeah.
what other questions do we have then?
Sorry, Megan, did you have, were you raising your hand, Megan? If not, I was going to continue.
Clap.
It was applause. I
Sorry.
thought the same thing.
Um,
Oh, I see a question from Bria. Do you want to take that one, Naz?
Sure. So Bria asked, or should I just reread the entire prompt? Okay. So Bria said, really interested in how you frame constraints as generative. Of course, constraints can be a pain. Constraints can be a pain when you're trying to complete a project, i.e. that low budget. But have you had experience purposefully employing constraints to come up with better ideas? So I think from my experience, I work a little bit more embedded into a specific operation in our company where we make a specific product. my involvement is as a quality engineer, I have to ensure that the product we make, comes out excellent without any issues. So oftentimes I am actually asking our operators, machinists, other engineers to, I'm giving them a stronger constraint than what is generally allowed. Essentially, I have to put in constraints on them to say, we need to meet a higher level of quality so that down the line we don't get issues with the customer. So one way I do that is we have, so I don't want to get too detailed, but essentially we have design reviews of prints or tolerances, and I have to ask some questions. How is this going to look coming down the line outside of our tiny siloed process here? Okay.
Yeah, and I'll just add on, I think one of the ways that we've looked at constraints before is we put like, when I've done a design thinking workshop at work, and pretty much one of the constraints we had during the workshop was, a fun one. We said, whatever you're currently trying to solve with your client, make it a game show. And make it something that you would want to play a game at, and it incentivizes it. And we got some of the most interesting ideas that honestly we could leverage as a new strategy for when we're approaching a client. And it's just funny because I think constraints are good, but in the sense that if you're always given the same constraints, you'll always think a certain way. So sometimes your constraints don't have to be like budget, time, and like we have on-time delivery, like we have all these like key performance indicators from a business level. But in a problem solving, I think, level, when you're thinking about designing and thinking about how do you want to approach a problem differently, we can add fun constraints, right? And another one is like, we had a roboticize your solution, and most people were like, oh my god, automation, workflows, and we're like, this is stupid. You need to think of more fun ones, like having Jarvis around and like answering all your questions. So it's fun though. It's a good way of adding constraints with a twist. So
Okay, so I think we can continue on to our presentation, right, Saba?
yeah, if there are no more questions, I'm ready to move.
Oh, there are a ton of amazing questions, but fear not. I think a lot of them will be answered through our presentation, and then the activity we'll do afterwards.
Okay, all right. And you guys can see my screen still, right?
Yep.
Perfect. Okay. So we're just going to get into what is design thinking, and I apologize if you already know about this, but design thinking is a human-centered design approach to innovation that draws from the designer's toolkit to integrate the needs of people, the possibilities of technology, and requirements for overall success. Design thinking was not developed by Stanford D School. The concept has been around since I think like the 60s, 70s. But what really happened is that the Stanford D School, with one of the professors, David Kelly, came in and made design thinking methodology and approach accessible to a broader community. So it wasn't like reserved for these PhDs in design thinking, it was for everyday members. And that's what really grew the movement. And they ended up founding this firm that's called IDEO, which is the Innovation Design Engineering Organization. And IDEO was formed to showcase that the design process can be modeled for the Stanford University students, but also for anyone else who wants to apply it to their day-to-day lives. And it's one of the ways that you don't have to be trained or like certified in design thinking. It can be modeled in if you are, whatever role you may be in, whatever your occupation. You can use design thinking even if you're a mom and you're trying to think, okay, what is a better way for me to prep my day if I have 3 kids who need to have lunches and I have all these other items to meet. It can really vary depending on what your personal preferences or your constraints are. So quick overview of the process. There's 5 steps usually, most commonly: empathize, define, ideate, and prototype test. We're really going to be focusing on the empathize, define, and ideate in this, and it's going to be the group breakout activity. We're not really going to be drilling down to this, super like insightful level. But what we like about this methodology is that because you guys are coming from all walks of life, we'll be able to really get that well-rounded perspective on the kind of issues that we've picked out for the group. And all right, now you're up.
Great. So how do we approach design for climate change solutions, right? So that's the meat of our presentation here. So as it comes to climate change, this is a unprecedented global issue that, 50 to 100 years ago, we would not have this in our mind ever. So that's a unique issue because we humans tend to use historical data to, fix the present issue, but that's not a crutch we can use right now. So this is where we believe design thinking can help. So we know that climate change is a global problem. The scope that Saba was giving, it seemed like we were working on personal issues. So how does design thinking work for a global problem? In fact, we find that for any problems that are too huge to comprehend, that's where design thinking is going to help you out the most, because it gives you a framework to take a gigantic issue and scale it down to a sustainable size. For design thinking, that size, it typically is a local community or a group of people where they're taking an issue that's affecting them personally and then creating a solution using local resources. Essentially, you can't just throw your money at, climate change happening halfway across the world and fix it. You need actual people working on the ground with results and solutions that they care about. All right, so I think I'm going to the next page. So what are some things we need to be aware of during this presentation, this activity for climate change solutions? Like I was saying, climate change, it's unprecedented. We're going to be working at a lot of extremes here. We are going to make some assumptions that, climate change is going to be the end of humanity, or maybe climate change is something that's going to happen over hundreds of years. There is going to be a lot of different assumptions using studies or different settings we'll be using in this presentation, but keep in mind that this is a really complex system of issues. We're not always going to make the correct assumptions, but we think design thinking as a framework is, you can always apply that and come to different results. So we hope you keep that in mind while you go through the activity afterwards.
Yeah, and key component of what design thinking is iteration. So you will always be iterating, and we can always come back and update, from new information that you learn. But just want to acknowledge that, we understand that you will not have a full breadth and understanding of what climate change really entails in terms of impacts, but we are going to be providing you with some context for the group activity, so that you have some information to reference as you are talking about the issues. So here's the introduction for a breakout room activity. And what we're primarily doing in the beginning will be reframing the problem. And reframing the problem is one of the most important aspects of design thinking, because what we have done is that we have I think we'll have about 4 to 5 groups. And we have presented you with this broader number one, what is the problem you're trying to solve? And we have framed it as a question for you. So it could be, I'll say, this is not one of the questions, but it'll be like, how can you make the subway system in New York City more climate change friendly? You can say, oh my God, that's kind of specific, but that's really broad. What do I mean when I say climate change friendly? And that's that's step 2, which is taking that broader question and narrowing it down to something actionable that you as a group feel that you can maybe think about and design around. There's the key outcomes. What that will do is that, okay, maybe when I say climate change friendly, we could say, oh, maybe it's trying to prevent kind of the damage that happened after Hurricane Sandy and mitigating that. And that's your actionable outcome that you can do. Then you'll be like, okay, what are my constraints? Well, do I know someone who works for the MTA who can provide? Is there anybody in the group? No. Okay, so that's one of my constraints. I don't have an understanding, but I do know how bad the damage was, and it was caused by flooding. We have somebody who works in water resource engineering. Let's go have them provide some input. And that's how you really are like kind of riffing, within the group to understand what is that outcome, what is that actionable challenge that we can resolve today. The last portion, which is 5, what are some possible solutions to your design question? That's going to be your ideation session. So that's going to be like really throwing out ideas out there, like based on the conversations you've had, based on the briefs that you're reading. And understand this, again, like we are not experts. We are not PhDs in design thinking. So we're not expecting you to be PhDs in design thinking. And we're not expecting you to have this glorious solution that will, address everything, but it will be a good way for you to understand the problem and what the solution could look like potentially. Any other questions right now? And feel free, yeah, if something doesn't make sense, I will repeat it or explain the activity more. And you will have facilitators, so you won't be by yourselves. So they will be guiding it.
Okay, anything else? Or should we go ahead and I just have a couple of things I need to say before.
Yeah, just one last slide. So we're expecting you to be uncomfortable because you don't have a lot of information. You feel like you're going to be making a mess and you might not be understanding it, but that's part of design thinking. And if you're an artist or if you're an engineer, messes are really common. It's good. That you might not feel ready. That's okay. We're expecting that. But being able to navigate that without knowing this is what makes part of a good designer. So Jenna, take it away.
All right. So we've provided questions for you.